Hello students, welcome to Sri Chayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 11 of laws of motion. In today's class we are going to discuss about the pseudo force. Yes, do you understand what pseudo is? Do you? Yes, it's a virtual force. Pseudo stands for virtual. So this is virtual force. Sometimes I say that we are going to learn the force which is not acting at all. Yes. So let's have a look what pseudo or virtual force is. But before we understood the pseudo, we must go through the inertial and non-inertial frames. So first we are going to discuss about the inertial and non-inertial frames. And from the concept of inertial and non-inertial frames, we are going to discuss about the pseudo force. So let's begin. First, inertial frame of reference. We can say it is a frames of reference in which Newton's laws of motion are applicable, and and these are the frame of reference if they move with the uniform velocity relative to each other. Yes, so these are the frame of reference. These are the frame of reference. Either they are at rest. That means if frame of reference is at rest, or it is moving, it is moving with uniform velocity. So if both or one of this condition is satisfied, that either they are at rest or it is moving with uniform velocity, then the frame of reference is considered as an inertial frame of reference. And and in this, or I can say it's an inertial, in the inertial frame of reference, Newton's laws of motion are applicable. Yes, all the forces, we can say normal force or the tension or the weight force, spring force, we have not discussed yet. We are going to discuss it in work power energy. Muscular force that we understood, all this force are came into the category where we take an observation in most situation in the inertial frame of reference. So in the inertial frame of reference, basic laws of physics are identical, and in all inertial frame of reference, and inertial frame of references are called as the Newtonian or Galilean frame of reference. So please remember this. Theoretical question can be asked from here. Yes, now let's look at the non-inertial frame of reference. What is it? If we say that frame of reference is in which Newton's laws are not applicable, and such frames are in acceleration relative to inertial frames. So if frame of reference is moving with accelerated or retarded motion, then it is non-inertial frames. So if frame of reference is moving with accelerated or retarded motion, then the frame of reference are considered as non-inertial frame of reference. I hope this is clear. This all are the examples of non-inertial frame of reference. You can take an example of accelerated car, or car going around a curve, or a merry-go-round, or the artificial satellites, or the accelerating elevators. This all, what you need to understand, that whether it is of inertial or non-inertial. How could I get it done? So a very basic fundamental is, if it is inertial, force acting on that frame of reference is zero, or you can take this decision from its acceleration as well, that acceleration is zero. If it is the case, then this frame of reference will be the inertial frame of reference. I hope this is clear. Okay, now what about the non-inertial? That if force is not zero. That means force is acting on it, or it is having an accelerated or retarded motion of, I'm talking about that frame of reference. Yes, if it is the case, then they are the non-inertial frame of reference. Now, all rotating frames of reference are non-inertial. Even the earth is considered as a non-inertial frame of reference. So, however, in many applications, the earth can be approximated as an inertial frame because the acceleration of the earth due to its rotation and revolution is negligible. So if please remember this, if on a strict sense, if we consider as a strict sense, earth is non-inertial frame of reference, but for practical purposes, for practical purposes we consider earth as an inertial frame of reference. Is it clear? Is it? Great. Let's have a look. These questions. Frame of references in which Newton's laws of motion are applicable. Yes, they are called as the inertial frame of reference. Yes, even the second name of the inertial frame of reference is the Galilean's frame of reference. So these two are the correct. So this would be the answer because it's both A and C is the correct. Is it clear? Great. Next, which is an example of non-inertial frame of reference. Non-inertial frame, that means I wish a force not equals to 0, acceleration not equals to 0, acceleration must be there, force must be there. So artificial satellites are there which came into the category of non-inertial frame of reference. Is it clear? Is it clear? Is it? Great. Now let's look at the pseudo force and its application. We are going to discuss this with its applications. Yes. So let's suppose look at this. It is observed that when we are traveling in a car and if the car hits a wall, then we feel a push in the forward direction. Yes, you can see this graphics, and from that also you understood the situation that according to this we cannot explain this phenomenon using Newton's laws of motion, because according to the Newton's law only external force can change the motion of a body. But here in this situation, when you are sitting in a car and certain force is acting on you, so we cannot apply Newton's laws directly in this situation. So what we need to understand is that when observations are taken from non-inertial frame of references, Newton's law cannot be applied directly. So this is the situation when we take an observations from non-inertial frame of reference, Newton's laws of motion cannot be applied directly. So in this situation we apply a pseudo force. On an object such that such that after applying applying pseudo force after applying a pseudo force, Newton's laws can be applied to it. Newton's laws can be applied. Yes. So the situation is that when and when observations are taken from the non-inertial frame of references, Newton's law cannot be applied directly. So what we are supposed to do is we need to apply a pseudo force on a certain object, and we used to apply a pseudo on certain object so that after applying a pseudo we can have and we can conclude Newton's laws on that body. Now how this all things will happen and what would be the situation, let's take one example and we are going to discuss the same thing. Let's suppose a box is there having mass m. Initially it is at rest. Now here a one car is there. Even at initial situation it is at rest. You as an observer are standing on the car. Yes, it's an open roof car and you are standing and you are looking at the box. So what do you say about the box? What do you say about the box? You will say that box is at rest and it is not in motion. Yes, this is your observation. Does it correct? Yes. Yes. Does it correct? Yes. Now, it is absolutely correct. Now, tell me one more thing. From where do you take your observations? That this is the situation that you take your observations from inertial frame of references. You take this observations from the inertial frame of references where Newton's laws are valid, or we can say Newton's law can be applied directly. I hope this is clear. Yes. Now the situation is that let's suppose this is mass m and at this point you were standing in the car. It is still at rest. It is still at rest. But now the situation changes and this car is moving with acceleration of a naught. Yes. And now you are looking at the box m. So what was your conclusion? Understand this situation, feel this situation practically and tell me. Even you can feel that when you are sitting in a car and you are just observing the outside the window, that certain trees are there on both the sides of highways, and you might have observed that trees are going behind. Do you remember this? Do you? Great. So here even you are going to see this, that box is having accelerated motion. What you are going to feel is box is having accelerated motion and it is moving in negative x direction with a naught acceleration. Now read this one more time. What you are supposed to observe is that this box is having accelerated motion. Even though it is at rest, you are going to feel this, that it is having an accelerated motion and it is moving in the negative x direction. and its acceleration would be the a naught. Now, why do you feel this? Why do you feel this? Because we make ourselves always on a rest. Yes, in a reality, you are moving with acceleration a naught, but what you feel is that I am at rest, but this box is moving outside. So why this kind of confusion has started and everything has been vanished? Because here observations are from non-inertial frame of reference. FOR. FOR stands for frame of reference. Yes, because here observations are from non-inertial frame of reference. I hope now are you clear that what would be the difference if observations has been taken from the inertial frame of reference and if observations are being taken from the non-inertial frame of reference. So if observations are taken from non-inertial frame of reference, then pseudo is required to be acted on an object. We are going to apply a pseudo force on an object. Now again back to that situation. This was box having mass m. Initial situation, it was an a naught and you were standing at this that. So I need to apply a pseudo. I need to apply the pseudo on block M. Now the pseudo force denoted as a P. Yes, P is silent. The pseudo force to be acted having a magnitude of mass m multiplied by acceleration a naught. Where look at this very carefully and understood this very carefully. This fp should be is equals to m into a naught. That this m, this is, or this should be the mass of an object on which pseudo is being applied. This is the mass of an object on which pseudo is being applied. Do remember this. And what about the a naught? What about the a naught? It is the acceleration. It is the acceleration with which your frame of reference is moving. It is the acceleration with which your frame of reference is moving. So this is pseudo force. This is pseudo force which should be is equals to mass into acceleration. This fp is equals to m into a naught, and where m stands for mass of an object on which pseudo is being applied, and a naught it is the acceleration with which your frame of reference is moving. I hope this is clear. Now very important task, a direction of pseudo force. Direction of pseudo force. That pseudo force always acts in the opposite direction to the direction of motion of frame of reference. So I hope you are clear with this. So understood this fully and one more time, but very quickly. So let's have a look. This was the first situation. This was the first situation in which box was at rest. You were at rest. So what you are observing? You are observing that box is at rest and it is not in motion. Does it correct observation? Yes. Why it is correct observation? Because you have taken your observations from the inertial frame of references, and in the inertial frame of references Newton's laws are valid, so there is no confusion in it and everything is clear. Now a confusion started where you have started moving in the car with acceleration a naught, but in a reality box is at rest and you are moving. Now what you are going to observe is that box is having an accelerated motion. Box is having an accelerated motion and it is moving in negative x direction and it is having an acceleration of a naught. Now does it clear observation or does it correct observation? From our heart and from our mind we understood that no, this is not correct, but what you feel, it is that only, that box is moving in the negative x direction because we have seen the trees are running behind, the shops are running behind when we are moving on the car. Yes. So what thing which is making this kind of falsy conclusion is that we have taken our observations from the non-inertial frame of reference. So first question is, where do I or when do I need to apply a pseudo force? If if observations are taken from non-inertial frame of reference, then pseudo is required to be acted on an object. Then and then you need to apply a pseudo force if observations are taken from non-inertial frame of reference. If observations are taken from inertial frame of reference, no need to apply a pseudo over here. Yes, look at this. Here observations were taken from the inertial frame of reference and everything is okay. So if observations are taken from non-inertial frame of reference, I need to apply a pseudo. Now how do I apply a pseudo? That, let's suppose I am moving in car with acceleration a naught and I am seeing this box, then I need to apply a pseudo on this, so then I can observe it very correctly. That I need to apply a pseudo on block M. The magnitude of the pseudo would be is equals to m into a naught, where m is the mass of an object on which pseudo is being applied, and a naught is the acceleration with which your frame of reference is moving. Now this is the magnitude, of pseudo force. Yes. Now direction of the pseudo always acts in the opposite direction to the direction of a motion of frame of reference. So if my frame of reference is moving in positive x direction, I need to apply a pseudo in negative x direction, and so on. So is it clear? Is it Do you understand this fully and conventionally? Yes. Okay, great. Let's work for the questions. That let's suppose this is a block M. You as an observer are here at rest. You are here. Yes. So first question, what is the magnitude of pseudo in this situation? This is the first situation. What is the magnitude of pseudo? So I will say that you are at rest. Box is always at rest. So here pseudo would be 0. Why? Because observation is being taken from inertial frame of reference. So pseudo does not require. You will take a correct decision. I hope this is clear. Is it clear? Is it? Great. Now, let's understand the second situation. This is block M. It is still at rest, but you yourself is moving towards the direction with acceleration a naught. So, do you apply FP? Do you apply pseudo force? Yes, FP would be there. Why? Because this is non-inertial frame of reference. I hope you understand this. So what would be the value, or what would be the magnitude of the FP? This FP should be is equals to mass times the acceleration. This is the object on which FP, I mean pseudo, is being applied. So in on this pseudo is to be acted, and it is the direction would be the positive x direction. Why positive x direction? Why positive x direction? Because the direction is opposite. Direction is opposite to the direction of motion of frame of reference. I hope this is clear. Is it clear? Is it? Great. Let's look at the third situation. This is block. It is at rest, and now you are sitting in an helicopter, and your helicopter is moving in the upward direction with certain acceleration, let's say a3. So FP would be non-zero because you are going to apply an FP. What would be the magnitude of FP? It would be a m into a3. What would be the direction? The direction was the FP would be in the negative x direction. So we can say FP is equals to minus of m into a3 j cap. Yes, minus of j to represent negative y direction. I hope this is clear. Is it clear? Is it? Ready for one more? Yes? Great. Let's do it quickly because clock is running high. It's a mass m. This is at rest. This is the block. And you have been sitting over something that is moving in this direction with certain velocity, let's say 10 meter per second. You are sitting on this. Yes, and this makes an angle theta, and this, let's say it is a theta. So what do you think? Will you apply a pseudo on it? Will you apply a pseudo on the block M? Will you? I should say FP should be 0. What was your conclusion? Is it same? Is it? Are you sure? Great. You understood it fully because as my frame of reference is moving with constant velocity, it is inertial frame of reference. Yes, it is inertial frame of reference, and as it is inertial frame of reference, pseudo would be 0. Now after this exercise, I hope you are fully clear with the pseudo force. Yes, that where to apply. First thing, always consider that from where you are taking your observations. If it is from inertial frame of reference, no need to apply a pseudo. You can go with it. Whatever we were doing conventionally, it is the same. Now if you are taking your observations, from a frame of reference which is moving accelerated or retarded, then you need to apply a pseudo. In which direction pseudo will apply? Then we will see that it is in the opposite direction. It will apply in the opposite direction of the direction of motion. What amount of pseudo should be acted? I will say it's a mass times of acceleration, where mass is the mass of an object on which pseudo is needed, and acceleration is the acceleration of that frame of reference on from which observations are being taken. I hope this is clear. Is it clear? Is it? Are you sure? Great. So now let's understood one practical situation using pseudo. Let's suppose a pendulum is there and which has been suspended from the roof of a moving car. So, a pendulum has been suspended from the roof of a moving car, and let's suppose this was the car, this was the pendulum, and this pendulum, we can say this bob is having mass m, which makes an angle theta with the vertical, and your car is moving in the positive x direction that has been observed. So if the car is moving with uniform velocity, then the position of the bob does not change. But if the car moves with acceleration or retardation, the bobs move in the opposite direction to that of the acceleration. So the situation is, if car is moving with acceleration a naught, then initially the bob was on this position, and now bob will be moving in this direction. Yes, this is the angle theta. Now what I want is that you observe this situation, from two point of view. One, standing here, this is the one location, and another standing on the road, and just observe the situation. This is the position B. So what does it make a difference, that we can discuss very clearly. So from where I need to take observation on a priority, on a first? From, tell me. Yes, from position B. Okay, let's begin. So from position B, I'm going to see this, and we will discuss our conclusions. That from position B, I'm going to observe this situation, that this is the bob, this is angle theta. So we understood that this is t, and if this angle is theta, from the geometry we can have this as well, this as a theta. This is t cos theta, this is t sin theta, and this is mg. So if I make a free body diagram, of this bob, it is something like this, that it is having a force that is of t sin theta in this direction. It is having a force, it's a t cos theta on the vertically upward direction, mg in the vertical downward direction. As car is moving with the acceleration a naught, and this bob is sitting in the car, so even it is moving with acceleration a naught, that means it's an m into a naught. So if I understand this, that horizontal acceleration of this bob is due to this t sin theta, so I can write like this, it's a t sin theta, that should be is equals to mass times of acceleration, and no vertical direction displacement, so I can write it's a t cos theta should be is equals to mg. This is my first, this is second conclusion. And if I take a ratio, it's a sin theta by cos theta, that is tan theta is equals to a naught by g in this case. I hope this is clear. Yes, we are going to derive the relation for the tension, but first I would like to see this complete situation from the position A. Now one more thing, when I take my observations from position B, I even mean that it is the inertial frame of reference. Yes, it is the inertial frame of reference from where I am taking my observations. I hope this is clear. Is it clear? Are you sure? Great. So this is the inertial frame of reference from where I am taking my observations. Now let's look the situation from the position A. So the situation is that this is the car, moving with acceleration a naught. This was the initial situation of the pendulum, and this is the final situation. This is theta, and you yourself are traveling in this car. So now if you take these observations, if you take this observation from point A, so from position A, let's have a look. This is theta. So same thing, it's a t. This would be the theta. This is t cos theta. This is t sin theta. This would be the mg. And one more thing, that now tell me, from position A, you are taking your observation. So are you sitting in a car? Yes. That car is at rest or in motion? Yes, your answer would be, sir, it is in motion, and even not in the uniform velocity. It is moving with accelerated motion. I hope this is clear. Yes, as it is moving in the accelerated motion, as it is moving with accelerated motion, that means I fully understood it, that this is non-inertial frame of reference. This is non-inertial frame of reference, and as it is moving in the non-inertial frame of reference, what I understood is that I myself is at rest, but the pendulum or this bob is moving in the negative x direction, and that's why I need to make a pseudo force on this. I hope this is clear. So is it clear? Now let's just redraw the free body diagram of the bob. So here it is having t sin theta, here it is having t cos theta, here it is having an mg, and here it is having the pseudo. Now what would be the value of the pseudo? It is the mass of a bob, which is m, and it is the acceleration. It's a mass into acceleration. We used to have it that m, it's a mass of an object on which pseudo is being applied, and acceleration, it must be the same acceleration. It must be the same acceleration with which frame of reference is moving. Now if I understood this very carefully and I make this at rest, if I make this at rest, that means t sin theta should be equals to mass times of the acceleration. T cos theta should be equals to m into g. Yes, this is first. This must be the second. Take a ratio, and tan theta is equals to a or a naught by g. Now just compare this relations. Just compare this relation with this. Even you taken your relations from the inertial frame of reference, your observations was lying on the same length, where your observations from non-inertial frame of reference were lying. It's a tan theta, it's an a naught by g. So you landed on the same answer. I hope this is clear. So please do understand that there is nothing like that if I apply a pseudo, I will have an answer, and if I am not applying a pseudo, I will not having an answer. If you observe the situations from inertial frame of reference, no need to apply a pseudo force. And if you are taking your observations, from the non-inertial frame of reference, you need to apply pseudo force. Yes, so there is nothing that from where should I see it, from where should I observe it, from where should I feel it. It is your call that whether I will take this observations from inertial frame of reference or non-inertial frame of reference. I hope these things are clear. Is it clear? Is it? So there is nothing like that if pseudo is applied, answer would be there. If pseudo is not applied, answer would not be there, or pseudo must be needed. No, it is not like that. If you don't want to apply pseudo, just choose a position where inertial frame of reference could be considered, and earth can be considered as an inertial frame of reference that we have discussed in the beginning slides. I hope this is clear. So is it clear where to apply and when to apply pseudo? Are you sure? Great. Now let's just find out the tension. Let's just find out the tension acting on the string. So the situation was, it's a t sine theta which was equals to m into a naught. It's a t cos theta that would be equals to mg. This was my relation 1, this was my relation 2. Now let's just square it and add it. It's a t square sine square theta plus t square cos square theta should be is equals to m square a naught square plus m square g square. So this is equals to t square into bracket sin square theta plus cos square theta, which should be a 1, should be is equals to m square as a common. It's a naught square plus g square. So this t tension is equals to m root of a naught square plus g square Newton. This much or this many Newton is acting as a tension force. I hope this is clear. Yes, yes. Is it clear? Completely, completely great. Now let's look a second and very famous application of the pseudo force. This is very important. Yes, one of the favorite applications of examiners. Now look at this. What does it say? What does it say is that a block is kept on a smooth inclined plane, can be kept stationary relative to the incline by giving a horizontal acceleration as shown in the figure. So what examiner is going to ask, that find out this force F or find out this acceleration A, so that this block is not moving with respect to weight and it is at rest with respect to weight. So what I need to do is that this block is having mass m, this block is having mass m, and I'm going to apply all the forces. I'm going to apply all the forces. So first I have applied the force that is of mg. This will make an angle theta because this is theta, so this is 90 and this would be the 90 minus theta, and as this would be the 90 minus theta, this is theta, it is making an angle theta with the mg. So this is mg cos theta, this is the normal force, this is the mg sin theta, and let's understood that I am sitting over here and I am taking this observations. I am sitting over here and I am taking this observation. So as I myself is sitting on a frame of reference which is moving, which is having a force F, that means I need to apply a pseudo. Where should I apply a pseudo? As my frame of reference is moving in positive x direction, I need to apply a frame of reference. I need to apply a pseudo in the negative x direction, and that pseudo will be having the value of mass into acceleration. So this is ma. This is ma, and if I make an components of it, it's an ma cos theta and this is ma sin theta. I hope this is clear. Is it clear? Is it clear? Are you sure? Are you sure? Great. So now if you make this block, in a situation where net force on it is 0, then you can have that that n, that means this m sorry, this acceleration would be equals to, if g tan theta, if acceleration is equals to g tan theta, then this block is not going to move with respect to which, that means the applied force should be is equals to F is equals to m plus m into a, because both are moving. This is the mass of the wedge, capital M, and this is having a small m of wedge. It's a F is equals to m plus m into a, and this a could be replaced by the g tan theta. It is the situation from where you are observing this situation from non-inertial frame of reference. I hope this is clear. Now a question might arise that, sir, if I observe this situation from ground, what will be the situation? So let's have a look. This is m, this is small m. I'm just doing this to make you satisfy that it is not something that you must observe it here, or from you must observe it from inertial frame, or you must observe it from non-inertial. Yes, this is the last attempt. Let's have a look. Yes, this is force F, and you are observing it from this position. You are standing on the ground and you are just observing it. That means you are at inertial frame of reference. So no pseudo would be required. And how this will done? Let's have a look. That this is the mg, and this is the angle theta. This would be the mg cos theta. This will be the mg sin theta. I hope this is clear. This is the normal. This is the normal, and this will make an n cos theta, because if this is theta, even this would be a theta, and this will make n sin theta. So this is the block M. It is having force n sin theta on this direction. It is having force n cos theta in this direction. It is having force mg on this direction, and as a force F is acting on this wedge, and this wedge and this block both are moving in this direction, I can write like this. It's an m into a. This acceleration is being provided by this n sin theta. So if I write this, it's an n sin theta should be is equals to m into a, and this n cos theta should be equals to m into g. This is relation number 1. This is relation number 2. If I take a ratio of this, it's a tan theta, which should be a by g. So this force that is acting, it's an F is equals to m plus m into a, and this a could be represented as g tan theta. So if I am able to apply this force, it's an F is equals to m plus m into g tan theta, then block is not having any relative motion with respect to wedge. I hope this is clear. So if block is not moving with respect to wedge, if you want that block should not move, apply this amount of force and block is not going to move. Yes, so observe this again. Yes, this was the situation where I used to sit on the wedge and observe the situation. Even whatever force I am receiving, it is the same force. It's an m plus m into g tan theta. Acceleration is the same. Even here the results are same. So this is the second time I have proved this, that if you observe it from inertial frame of reference, it would be the same answer. If you observe it from non-inertially. Only the difference is that if you take observation from non-inertial frame of reference, you need to apply a pseudo. And if you observe this from inertial frame of reference, do not apply a pseudo and make things done. I hope this is clear. Is it clear? So please understood. Yes, always take your stand that I will observe this from here and apply the forces accordingly. Yes, is it clear? Is it clear? Any issues in this? No? Great. Now let's observe one more thing in this question, that in the previous question find out force acting between wedge M, force acting between wedge having mass M and block small m. Yes, so the situation was, we used to have this as the relation, that n sin theta was equals to ma, and this n cos theta, this is equals to mg. Yes, this n sin theta is equals to ma and n cos theta is equals to mg. If I'm going to add this, that means square it and add this, It's a n square sine square theta, which should be equals to m square a square, and n square cos square theta should be equals to m square g square. So if I'm going to add this, it's an n square sine square theta plus n square cos square theta. It's an n square, which should be is equals to m square into bracket a square plus g square. Is it clear? Now I am having this. It's a n square that should be is equals to m square into bracket a square plus g square. I know that a is equals to g tan theta. A is equals to g tan theta. So this is could be written as m square into a square, which is equals to g square tan square theta plus g square. So that should be is equals to m square g square into 1 plus tan square theta. It is the sec square theta. This is equals to n square, and could be written as n square is equals to m square g square divide by sec square. It's a cos square theta. So this is the force that is acting. N is equals to mg by cos theta. Yes, I hope this is the clear. This is clear, and this is the location where student might get confused. Why? I don't know, because student might select the force that, yes, what they ask, the force between m and m. So what student is used to have, it's an n is equals to mg cos theta, and they are just writing it that n is equals to mg cos theta. Yes, this would be the option, but this is incorrect one. Even you should not go for this. The normal force which is being acted, a normal force which is being acted between block M and wedge M, is mg by cos theta and not mg cos theta. Please do remember this. Even I'm going to rub this from here. Yes, I hope this is clear. Is it clear? Is it? Great. So let's look at one more application, even one more very interested application of same thing. Now look at this. What does it say? It says an object of mass m is kept on a wedge of mass m, and the wedge is moved with an acceleration a such that the object moves down like a freely falling body, and there is no friction. Even in the previous application there was no friction were there, and we were used to have that magic kind of thing. Let's create that magic again. This is the situation that this is theta. A wedge is having a mass m. A block must be over here, and it must be having mass m. What you need to do is you need to apply a force in this direction such that this is having a free fall. This block is having free fall. Now how could you do this? How could you do this? Let's just try to apply all the forces that we understood. It's an mg. This is theta. This is mg cos theta. This is mg sin theta. Now let's see it over here. Yes, and observe the situation. That means I'm taking my observations from the non-inertial frame of reference, and as I'm taking my observations from the non-inertial frame of reference, I need to apply a pseudo. Now my block is moving in this direction, so I'm going to apply the pseudo in this direction. It's an m into, let's say, acceleration is a. If this is a, that should be, if this is angle theta, even this must be angle theta, so this should be ma cos theta, and this would be the ma sin theta. Even this was the normal force. I hope this is clear. Is it clear? Is it clear? Great. Now what you required that object moves down like a freely falling body. So when object free falls, it is not having contact with wage. Yes, it must not have any contact with wage. And if it is not in contact with wage, a normal force should be 0. Yes, this is very important aspect of this situation. So normal force acting on it must be 0. So now if you observe the situation, the vertical forces, it's an ma sin theta, it's an n, and it is mg cos theta. They are on the same line. So we can write like this, it's an n plus ma sin theta should be is equals to mg cos theta. Now in this case, as it starts free falling, n should be 0. So I can write like this, it's an ma sin theta should be is equals to mg cos theta. This mass has gone, and a could be written as g into cos theta by sin theta. It's a cot theta. So if you can apply a force on wage m with acceleration of g cot theta, that means if total force of mg cot theta, if total force of F, that is mg cot theta, can be applied on this wage M, then block M will be having free fall. This block M having free fall. I hope this is clear. And what is the force between wage M and small block M? Force between wage M and block M is 0, because they are not having any contact. No friction is there. They have been lost their contact, and when they have lost their contact, force between wage M and block M is 0. I hope this is clear. So please do remember this, both the applications. This are very important application according to the examinations. Please do remember this. This is required. Now let's work for the one of the numerical. What does it says? It says that a ball is suspended by thread from the ceiling of a tram car. Okay, and brakes are applied, and the speed of the car changes uniformly from 36 km per hour. That means initial velocity is given, it's a 36 km per hour to 0. That means the final velocity, it's a 0 meter per second. A time is given, that is of 5 seconds. Okay, the angle by which the ball deviates from the vertical. Okay, this is required. Okay, so we understand that this might be the situation. This was the tram car, and here the pendulum may be there, and this is the angle theta. This is the angle theta which it is deviated, and it must be moving in this direction. So what I can have is, it's a tan theta which could be written as a naught by g. This a naught can be represented as delta v by delta t, and the delta v, it's a 36 km per hour. That means if I convert this, because this is in SI unit, it's a 36 multiplied by 5 by 18, which should be 10 meter per second. Yes, 18 2s are 36. Yes, so it's a from 10 to 0 within 5 seconds, it's a 2 meter per second square. So that should be 2 divide by 10 should be equals to 1 by 5. So I hope these things are clear. So this is that tan theta should be equals to 1 by 5, or theta should be equals to tan inverse of 1 by 5. I hope this is clear. Is it clear? Yes, this would be the correct answer. Yes, is it clear? Are you done with this? Great. So let's just wind it up the session over here. Yes, this was all about the pseudo force. Yes, now you must understand when to apply pseudo, when to not apply pseudo, and everything about the pseudo force. Yes, so practice a lot, practice this kind of questions a lot. This is, here we have discussed all the forces that we need to discuss in the laws of motion. Yes, we are starting with the weight, then the normal, then the tension, then the friction, then the centripetal, because that is the force that acts on the circular motion, and now it's about a pseudo. Yes, so now you can do all the questions, every questions that have been related with forces. I hope this is clear. Yes, practice a lot. Practice will save us. It will make you more accurate as well as more speedy. Yes, please do it. Please at least solve 40 to 50 questions each day, every day. Please do it. It is essential. Thank you. Have a good day. Take care. Bye bye.